As I told you already, we will be starting with a new uh, tool, that is Docker, one of the very important tools in DevOps, which is Docker. So you may have already heard of this Docker and all, Docker technology and all, but let us discuss this in more detail. What is Docker? Why it is used? What are the different commands that are used in Docker, etc. So this is all we are going to discuss today. Before that, let me pick up this Docker logo. Okay. Now Docker is a containerization tool. So in case if they ask you to explain this in one line, Docker is a containerization tool. That means it is used to create the containers. Now what are containers and how are they different from virtual machines? So Akshay had asked a question in previous batch, sorry, in the previous sessions, that can we do virtualization, or what is the method, like what is the best practices that are used instead of virtualization? Can we do virtualization on top of virtualized machines? So that concept is called as nested virtualization. So we will not go in that detail, but let me show you a very interesting thing. As compared to virtualization, there is another process or technology which is called as containerization. So in order to understand containerization, we should also understand what is virtualization. Now, let's say for example, you have your physical server. Okay, so let's say this is your physical server, and in this server, you already have an operating system. So let's say, for example, you have your Windows operating system. You have already installed Windows operating system in this physical server. Now, this physical server, you can consider any physical server that is used by the organization, or let us consider our laptop as well. You can take any example. You can take laptop as an example, or you can take physical server as an example. So we are already aware that on top of this hardware, a software will be installed. Now, in our case, the software is Windows operating system. Okay. Now, but let's say I have a requirement that on top of this Windows operating system, I want to set up additional operating system, or let's say I want to run different operating systems. So let's say for example, on top of Windows, I want to run Windows XP, which is no more in use, but let's say I want to run Windows XP. So I have a requirement, let's say that there is an old software which requires Windows XP. So I want to let's say configure Windows XP on top of this Windows uh, operating system. So let's say this is Windows, let's say 10 or 11. Let me consider this as Windows 10. I have Windows 10, and on top of it I want to set up Windows XP. And along with that also I have a requirement that I want to set up Windows 7. So I have another operating system which is Windows 7. So this is also I want to configure, or I want to install it on top of my physical server, or let's say in my laptop only I want to install Windows XP and Windows 7. Is that possible? The answer is yes. How? With the help of virtualization tools or virtualization softwares. So if you want to run multiple operating systems on your physical servers or even in your laptops or even in your personal computers, then that is possible with the help of virtualization. That is possible with the help of virtualization softwares. Now, the popular virtualization software that we are already aware is VMware. So, VMware provides you with virtualization softwares wherein you can configure multiple operating systems in the same physical server. So, VMware is a kind of a software using which you can configure multiple operating systems in your physical servers. There are other tools as well, but this is the popular one. So using VMware, you can install a software inside your physical server, or let's say in your laptop you can install VMware, and with the help of VMware you can set up multiple operating systems. Not only Windows, you can also set up Linux operating system as well. So let's say I want to install Red Hat operating system in my machine. I can easily do it with the help of virtualization software like VMware. Now this is a technology using which you can run multiple operating systems within the same physical server, and this is the same technology which AWS has used. So AWS, I told you already that they have physical servers spread across the world. Okay, and on top of it, they have installed a virtualization software. Now AWS uses a virtualization software called as Hyper-V. Okay, so as far as I'm aware, that it uses Hyper-V on top of its physical servers, using which or because of which we are able to run multiple operating systems on top of AWS. So the moment you create AWS account, you can create a Windows machine, or you can create a Linux machine, or you can create Ubuntu machine, and that is possible only because of this virtualization software, which is Hyper-V. Or maybe it uses something else, but as I'm aware, it uses Hyper-V. Or let's say that it uses some virtualization software, because of which we are able to run multiple we are able to run VMs with different operating systems, right? Now that is called as a virtualization technology. Okay, so that is what virtualization means. So simply put, because of virtualization, on the same physical servers, you can create multiple virtual machines which uses different operating system. Now, but there is one limitation here, that when you are creating multiple virtual machines, it it requires, or it needs that, we need to allocate a dedicated CPU and RAM for them. Okay, so let's say for example, this physical server is having 32 GB of RAM, and let's say 16 virtual CPUs, or it has 16 CPUs. Then what will happen is you have to allot a separate RAM to these machines as well. So they will have minimum requirement of RAM. So let's say Windows XP can run with 2 GB of RAM, and let's say one virtual CPU. That is enough for it because it is Windows XP. But Windows 7, it requires more of a RAM. So let's say it will require 4 GB of RAM. So it will require 4 GB of RAM, and let's say two virtual CPUs, because it is Windows 7. And for Linux, Linux won't take much of RAM and all, but you have to allocate a dedicated RAM and CPU to these virtual machines. Now these are called as virtual machines. Why? Because they are created within the physical server. That is the reason why they are called as virtual machines. EC2 instance is an example of virtual machine. Why? Because we have created it on top of a physical server, and within that physical server we have our own, we provide our own requirement of RAM and CPU, and on top of this, on the from that physical server, a separate resource will get allocated, that is a separate RAM and CPU will get allocated to that EC2 instance. Okay, so EC2 instance is an example of virtual machine. Now you see that out of 32 GB, 2 GB will be taken by Windows XP, 4 GB will be taken by Windows 7, 1 GB will be taken by let's say Linux machine. So this physical server will be left with 32 minus 7. Okay, so 2 plus 4 plus 1 is 7. So it will finally what will happen is 32 minus 7, which is approximately 25 GB of RAM will be left for the physical servers, and 2, 3 and 3.5. So 16 minus 3.5, which is 12.5 virtual CPU will be left to this physical servers. So it will be left out with these configurations. So whatever services or whatever activities we are doing on top of these physical servers, we will be only doing it from this RAM. Okay, because out of this RAM, 7 GB RAM is already taken by the virtual machines, and 3.5 virtual CPUs is already taken by the virtual machines. So this physical server will be left with less RAM and less CPU. Okay, so that configuration will decrease because the virtual machine has already allocated their own resources. So what will happen is the physical server will be left out with lesser RAM and CPU, and it has to function within that configuration. Maybe let's say there are some applications which need minimum of 32 GB RAM on top of this physical server, then those applications will either not work, or they will work very slowly. Okay, they will start responding very slowly. Why? Because minimum 32 GB RAM is required, but only 25 GB RAM is left. Okay, so this is one limitation that occurs on when we are using virtual machines. Virtual machines, they need dedicated resources. They need dedicated RAM, they need dedicated CPU, and they need dedicated storage. And this limitation gave rise to a technology which is called as containerization. Okay, because of this limitation that arises in the virtualization, okay, virtualization technology, this gave rise to a technology which is called as containerization. Now what happens with containerization is, let me take this, let us differentiate now between virtualization and containerization. You will have your base machine, you will have your base physical server. This physical server will have its own operating system. Okay, it can be Windows or Linux. So let's say we here I will consider Linux. It will have its own uh, base operating system. So let's say for example it will have Linux operating system. Now see, containerization can be done on physical servers, it can also be done on virtual machines. So we will discuss that in some time. Now here, this virtualization software got replaced with containerization software, or let's say containerization packages like Docker. So this virtualization got replaced with containerization software like Docker. And what Docker, using Docker, what you can do is you can run operating systems. Now let's say the base operating system is Linux, and on Linux, let's say I want to run Red Hat or Ubuntu. I want to run Red Hat or Ubuntu or let's say Amazon Linux. Then that is possible without having to dedicate separate resources to them. So these operating systems can run without having to dedicate them separate resources, as in you don't have to dedicate separate RAM and CPU. They will use the base machine resources only. They will be using the base machine resources like this, and you don't have to allocate a separate RAM and CPU to them. Now the question is, then how do we install the operating system? Because here what you have to do is you have to install the operating system from scratch. Okay, you may be aware how to install the operating system in your machine. So all that process will be followed. So let's say if I want to install Windows 7, I have to take that Windows DVD, or let's say I have to set up Windows in my pen drive, and I have to install Windows from scratch. But with the help of containerization, you don't have to install the entire operating system. Okay, it will also consider the base operating system. So here in our case, it will consider most like the operating system Linux. It will take all the important components from Linux and additional whatever differences are there, because see, Linux, there are some differences among the flavors, right? So the Ubuntu, Amazon Linux, Red Hat, they have slight differences. So whatever differences are there, that additional differences will be downloaded, that's it. So that differences can be 5% to 6%, 7%, whatever differences are there, whatever additional files or additional system files that are required or libraries that are required, that will be downloaded. Okay, that's it. But the operating system will not be installed from scratch. You don't have to install the operating system from scratch. You have to just download the additional we can say files that are required for this operating system. Because see, from Linux, Amazon Linux is derived, but there will be slight differences. So now these 5% can be hardly of MBs, let's say 100 MB, or let's say 200 MB, like that. So these additional files of 100 or 50 MBs or 100 MBs, they will be in small sizes that needs to be downloaded. So you have to download these additional files which are in few MBs, and that's it. With the help of these additional files, you will be able to configure, or you will be able to run mini virtual machines. Now I'm calling it mini virtual machines. Okay, just remember this. Now these are like mini virtual machines. So they are similar to virtual machines, but the difference is that you don't have to install this operating system from scratch. First thing, you don't have to dedicate separate resources to them. Second thing, that you don't have to dedicate separate RAM and CPU to them. That is not at all required. Okay, and third thing, whatever additional files are there, that will be downloaded. So it will not download the entire operating system. In the case of Windows or even Linux, the entire operating system is in GBs. Okay, it can be around 4 to let's say 8 GB of size. Okay, so the entire operating system can be in several GBs. It can be even more than 8 GB, but let us consider it can be in some GBs. Here you have to install the entire operating systems, and that entire operating system will be in some certain GBs. But here that is not required. So this it is like installing a mini virtual machine with which will be using the base machine operating system. So it will be taking the base machine operating system, it will be taking the base machine resources, and you will be running tiny machines on top of your physical server. And another advantage of this is that if these tiny machines are not in a running state, they will not consume any resources. Okay, so your 32 GB RAM will be free if all these three machines, or all these three tiny machines, are not in a running state. Now these tiny machines are called as containers. Now these tiny machines, they are called as containers. Now technically they are called as containers, but just for your understanding, you can also call them as tiny virtual machines. Now this is a Red Hat container, this is an Ubuntu container, and the other one is the Amazon Linux container. So technically they are called as containers, but just for your understanding, you can call them as tiny virtual machines or mini virtual machines. Okay, whatever you can call, for your just for your understanding, you can call them as mini virtual machines, but technically they are called as containers. So now let's go back to the logo of Docker. So this is a ship, or let's say a blue whale, or the ship which is in a form of in a shape of blue whale, and top of it you have tiny containers. So that means that this ship is like the base machine, and on top of this base machine you are running multiple small virtual machines, and these machines or small mini machines, they are called as containers. So this ship is carrying multiple containers. Now this container can be of Amazon Linux, this can be of Ubuntu, this can be of Red Hat, this can be of SUSE, etc, etc, right? So this is what containerization is. So the difference between virtualization and containerization is that virtualization is used to create virtual machines which will have its own dedicated RAM, CPU, and you have to install the entire operating system from scratch, and that operating system can be in sizes of multiple GBs. And as compared to containerization, these containers, they will be consuming the base machine resources. It will be consuming the base machine RAM and CPU, and it will only download the additional files that are required for these operating system, and they will not, you don't have to install this operating system from scratch. So the configuration of this container is quite easy. Okay, so you have to just first you have to install Docker, obviously, in your system. After you install Docker, you can easily create containers. Now this is what Docker is. Now the question is Docker the only tool that is available in market? The answer is no. There are other tools as well, okay, that are available in the market, but Docker is the popular one. Okay, so I am talking about the containerization tools. We have several containerization tools that are available in market. So Docker is one of them. It is one of the containerization tools. Then we have Rocket. Then we also have Containerd. We also have Podman, and there are many more. Okay, so these are the other, like, several containerization tools that are available in market, but Docker is the popular one. Okay, so Docker is used in most of the organization because of its several uh, other features. So you may also come across Containerd or Rocket or Podman, but Docker is the popular one. So if you learn Docker, you will be learning containerization process. Okay, so let's say in future, if some company is using Podman, you should also be able to work on it because you are already aware of the uh, containerization, we can say, process or technology. So once you are aware of one technology, you can work on other tools as well. Okay, so that obviously you have to just understand the differences. Maybe that may hardly take you 1 or 2 days, and after that you will be able to work on other tools as well. So understanding one tool is important to understand the technology, and once you understand the technology, you can work on other tools as well. But as I told you already, Docker is used in most of the organizations. Now let us understand why Docker is required. So we have discussed this virtualization versus Docker. Now let us understand why do we need Docker only, or let's say what are the different features of Docker. So the first advantage of Docker is that it is free and open source. It is free and it is open source. You can easily download Docker from the internet. So it is available free. Second thing, it is economical. That means that you don't have to uh, let's say download the additional whatever operating systems that you are downloading, they are not available for free, right? And that will be consuming sizes in GBs. So that is the reason why Docker is economical, because all you have to do is you have to create a virtual machine. So let's say I've created a EC2 instance. As I told you already, Docker can work on physical servers and it can also work on virtual machines. So let's say on top of virtual machine, you want to do additional virtualization. So for that, we will be using Docker. So let's say I've created an EC2 instance. So this is my EC2 instance, and this EC2 instance is, let's say, of 32 GB RAM and 16 virtual CPUs. And for this, I am paying around, just for example, let's say I'm paying around $5 per hour. Like, these are the charges that I am paying for this virtual machine, just for an example. Now, let's say I have a requirement wherein I want to run an application in a different, I want to isolate that application, I want to run it in a different virtual machine. Then what I will have to do, I will have to create another virtual machine. And let's say I have another requirement for testing another application, then I again have to run, or I have to configure another virtual machine or another EC2 instance. What this will do is it will increase the cost to 3x. This will increase my cost to 3x because I'm just creating number of EC2 instances. Instead, what I can do is, whatever application that I want, I will install Docker and I will create a isolated environment here. Okay, I want to run it in a different operating system. Let's say I want to run it in Amazon Linux, for example. So I can create a EC2 I can create a container with Amazon Linux operating system, and I can just test that application, or I can make use of that application, or that application can run continuously. So I don't have to worry of paying additional charges. I am making use of other let's say operating system. I am isolating the environment. I am using multiple, I am running multiple operating systems in my machine, but I don't have to pay the additional charges. So containers will not, you don't have to pay additional charges for the containers. So these containers are free. Even if you can create hundreds of containers in your EC2 instance, this charge will not get affected because you are paying the charges for the EC2 instance. You are not, you cannot, they will not charge you for the containers that you are creating within the EC2 instance. So that is the reason why you can call it as that it is economical. Okay, you can create several number of EC2 instances, but in the same price of your EC2 instance, sorry, you can create several number of containers, but at the same price of your EC2 instance, you can work on multiple applications. So that is why we can say that it is economical. Third thing, it is, containers are lightweight. Now I told you they don't consume additional resources, they don't consume additional RAM, CPU, they don't even take much of the space in your system. And since they you don't have to install these containers from scratch, they are very quick to start and stop. You can easily you can easily start and stop these containers in a fraction of seconds. As compared to the virtual machines, virtual machine need at least some few minutes to start. But as compared to the containers, containers can start quickly within fraction of seconds. And that is what they are lightweight, and along with that they are quick to start and stop. You can easily start these containers and you can easily stop these containers. So they are quite quick to start and stop. So let's say if you have some application and you don't want much of a do you don't want to give much time for this application to start. Okay, so you want to reduce that starting time. Okay, for that you can make use of this container, right? So they are quite quick to start and stop. That is another feature of containers. And as I told you already, they will consume less package size. Okay, so these operating system that we will be installing additionally, the package size will be hardly in MBs. Okay, so their package size will be hardly in MBs as compared to the virtual machines, wherein you have to install the entire virtual machine, and that will need they will consume some space of few GBs. And using containers, you can replicate a consistent environment. Okay, so you can create containers and you can just replicate, and you can you can have a consistent environment. Okay, so you will be having you can create multiple containers and same environment you can create. And that is why this is another feature of Docker, that you can work with consistent environment. Okay, or you can create consistent environments. Now I have told you already that it uses the host machine RAM and CPU. Okay, so that is already aware. And you can easily create images. So from these containers you can also create images. You can create images from these containers. And these images you can share it with others, and you can share these images with others. So it is quite similar to AMI that we had discussed. If you remember, we had discussed AMIs in EC2 instance, wherein we can create AMIs from our EC2 instance and we can share the AMIs to others. And that is the same thing that you can do in containers as well. Just give me 1 minute. Okay. So from these containers, you can create images, and these images are shareable. You can share these images to with others, and from these images they can create containers, of the same whatever installation that you have done in the containers. They can create their own containers out of these images. And this is the same concept that we had discussed in EC2, right? So we had discussed how we can, from that EC2 instance, we can create images, and these images are shareable. From that images they can create their own EC2 instance. Likewise, from the containers you can create images. These images can be shared with others. Now, in EC2 instance, we had discussed about the AMI marketplace. If you remember, these AMIs are available on AWS portal, and from that portal you can download these images. But what about the Docker images? Where are they available? So these images are available in a web portal which is called as Dockerhub. So we have a web portal provided by Docker which is called as Dockerhub, wherein you can push and pull the images. You can store the images. This is kind of a marketplace for storing the images. Okay, so you can store these images in a marketplace as in AWS itself is a kind of a marketplace from where you can you can download the images. For Docker images, we have a web portal which is called as a Docker Hub, using which you can store these images either publicly or privately. If you want to create private images, that can also be done. Okay, so you can create public images or private images, and you can store these images on a web portal which is provided by Docker, which is called as a Docker Hub. And from these web portals only, others can download these images. Okay, so these images are available here, and these images are downloadable. Now, I told you already that it also supports the physical server. Although we will be creating containers on EC2 instances, but it also supports the physical servers. Okay, so it also supports, that is where we started already. It also supports physical servers, but we will be creating containers on top of virtual machines, or let's say EC2 instances. And it also supports cloud. So that is where we will be creating the EC2, we will be creating the containers within the EC2 instances. Now moving ahead, uh, let us understand what all components Docker contains. Okay, so the moment you install Docker, you will get a Docker CLI. Okay, so obviously using which you will be running the Docker commands. So you will get the access to CLI. So Docker CLI is command line interface wherein you will be running the Docker commands. Like for example, Docker images, or let's say Docker ps-a, Docker RMI, Docker RM, etc., etc. So all these commands you will be able to run because of this Docker CLI. Then the next part that you have is the Docker engine itself. Now Docker engine nothing engine means a package. It simply means a package. So Docker engine is nothing but a package. Okay. So it is a software which is used to create, manage, and run the containers. So because of this, you will be able to create, or let's say manage or delete the containers. So let's say you have containers here in your system. You will be able to delete or add or modify these containers because of this Docker engine. So the container management will be done because of this Docker engine only. So that is what Docker engine is responsible for. Now there is another component which is called as the container runtime. Now one thing that we should be aware is that container runtime, it is a component which manages all the container processes. So let's say the container creation, container deletion, storing of the container, the networking of the container, that is done by the container runtime. So next component, it is responsible for the container components. So let's say these are three containers. I want to do networking, that will be done with the help of container runtime. I want to send some files across these containers. So the whatever activities that we'll be doing with these containers, that will be done with the help of container runtime. So connecting these containers together, communicating with these containers, or sending files across these containers, and all these activities will be done with the help of this container runtime. Now previously Docker had a different container runtime, but now by default Docker uses container D as the container runtime. So one thing to note here is that container D is not only a containerization tool, but it is also a container runtime. So container D, both it is a container software, it is as well as container runtime. Okay, it does both the activities, but Docker uses container D as the default container runtime. In previous versions of Docker, Docker had its own container runtime, but in the recent changes, okay, the recent versions which Docker uses container D as the container runtime. So what is the runtime functionality of runtime? Nothing but the networking of the containers, container creation, container storage, or transferring some data across the containers. Whatever activities that we do, that is done by the container runtime. And Docker now has used container runtime, container D as the default container runtime. Although in the previous versions, container Docker had its own container runtime, but now this container D is a default container runtime for Docker. And then we have the Docker API. So it is API is nothing but using which you will be interacting with Docker, right? So that is what API means. So API is programmable interface. Nothing, simply put, it is the interface using which you will be interacting with Docker. That is what an API means. So these are the four important components that are, let's say, that are created the moment you install Docker in your system. Okay, so these are the components that the Docker will be providing you with. So you have the CLI wherein you will be running the commands. This is the Docker engine. So that is the software which is responsible for managing the containers. Container runtime is responsible for networking of the containers, container storage, etc., etc. And Docker API is the interface using which you will be communicating with Docker. Moving ahead, let us understand what are the different. This we have already discussed. So we have already discussed what is a Docker image. So Docker image, as I told you already, it is similar to that Amazon machine image. So these images are shareable, and these images are available on the marketplace provided by Dockerhub, right? Now let us understand what is a Docker file and some rules to create Docker container. So let us understand what is a Docker file. Now let me come back here. Okay, so let me pull this container here. Now I told you that containers are created from the images, right? So you will be having the images which are available on Docker Hub. So from the Docker Hub, you will be downloading the images, and from these images, you will be creating the containers, right? But how do I create the images? Okay, so let's say I have already an existing container. How do I create images? So for that, we have something called as a Docker file. So you can create images with the help of a Docker file as well. So there are images that are available ready-made on Docker Hub. That images can be pulled. Okay, so there are certain images that are already provided by the Docker community. But if you want to create your custom image, then that can also be created with the help of a Docker file. So if you remember in AWS, what we did, we installed an operating system, or we installed an operating system. On top of it, we had installed some softwares, and we had created an AMI. Okay, So that is kind of a creating a custom AMI, right? We had installed some additional packages and we had created an AMI that is kind of a custom image that we created. So these custom images can be created by writing a Docker file. Okay, so you have to write the Docker file, and by writing the Docker file, you will be able to create the images. Now there are certain rules that needs to be followed while writing a Docker file. Now let us discuss those rules. So here this file is just a simple file, and this is a standard naming convention that you have to give. This is how you have to write Docker file, without a space, without a hyphen or underscore, and the D has to be capital. Okay, this is how you have to write a Docker file. That is the first rule. And this Docker file is nothing but it is a file with some set of instructions. So this is just a simple file, but there are certain rules that we have to follow while writing the Docker file. So let us discuss these rules here. So first of all, you have to use the trusted images. So the first line that you will be using here is from, and from followed by the image name. Okay, which image you want to use. That it can be a Ubuntu image or Amazon Linux image or any custom image. So here you have to mention the image name. So that is the first rule while you are writing a Docker file. Second rule, you will be using a command called as run. So we will be discussing this Docker file in more detail in practical, but at least theoretically understand that what are the important rules that are required to be followed while writing a Docker file. And this question can be asked in interview, that what are the standard practices for writing a Docker file. Then we have another command which is called as a run, using which you can run the Linux commands. For example, let's say apt install git-y, or you can also use apt update -y. So the rule is that if you are using multiple commands, always combine these commands in single line with the help of ampersands. So like you can use this ampersand and you can combine multiple commands, and you can just use this command in a single line. That is what is called as an ampersand. So this is like combining the commands. Or you can also use OR operator, which is two pipes. This is pipe, okay, which is just above your enter button. So these pipes also you can use if you either you want to install Git or you want to update the operating system. Either of the way, whatever commands that you are running, you have to run it in a single line. That is the second rule. Third rule is that you have to always label your Docker file. Okay, the same way where we had discussed about writing the shell script, we had always mentioned the author name. Similarly, here you have to mention the label, and inside the label you have to mention the author name or who has written this Docker file, and the description. What is this Docker file all about? So that needs to be mentioned inside the label. So label is a command wherein will be mentioning the author name or who is the owner of this Docker file. You will be mentioning the owner name and a small description if possible, what is this Docker file all about. Then the next rule is that you have to always do the health checks using the health checks command. So okay, you have to always do the health checks. Okay, so rather than creating the containers and directly sending the traffic over here, first it is always recommended to do a health check. If the container is healthy, then only the traffic needs to be sent. If the container is not healthy, the traffic should not be sent here in this container. So always use a health checks to check the health of containers, or let's say send traffic to healthy containers. So if your containers are not healthy, the traffic won't get routed there, and then you will start getting some errors. So always do a health check, and using the health checks you can send the traffic to healthy containers. Then the next rule is that always create a normal user. Don't run the commands by being a root user. So use normal user. Don't run the commands by being a root user. So this is another standard practice that is followed by for while writing a Docker file. Then if there are any environment variables, okay, So you have to set the environment variables rather than hard coding them. So here you can make use of env. So you can make use of env and you can set the environment variables. So rather than using them in the later point of the code, okay, after creating the containers, if you're trying to set the environment variables, rather than doing that, just set the environment variables at the start itself. You can set the environment variables inside the Docker file by using the command env. And organize the Docker file with less frequently used commands at the top and more frequently used commands at the bottom. Now, why do we need to do this? Is so that we can easily scroll at the bottom and look ahead, look for the frequently used commands. Okay, so the less commands should be mentioned here, and at the bottom, the frequently used commands has to be mentioned. So the commands that are used less frequently will be at the top, followed by the frequently used commands should be at the bottom. Testing needs to be done. Okay, so you have to always use the Docker file. You have to first test the Docker file. So just to check that the apps are working as expected. Okay, so it can be either done manually. You can manually test the Docker file. You can just create images, run the containers, test the containers. That can be done either manually, or you can use the CI/CD tool like Jenkins. From Jenkins, you can run the Docker containers, or you make use of other third-party tools. But mostly we will be doing this testing manually. Okay, so that we will be doing later on at the later part of time. And the next tool is that always use Docker ignore. So if the Docker ignore is same as git ignore, so if there are certain files that you don't want to push, okay, in that Docker image, then you can simply use Docker ignore. So Docker ignore is the same file, or let's say it is a similar file as git ignore. So use Docker ignore for to avoid sending unnecessary files. So if you don't want to push any uh, unnecessary files or some sensitive data, you can make use of this Docker ignore, and this is written like this: dot Docker ignore, same as git ignore. If you remember, we had used dot git ignore, which used to avoid sending the files to GitHub. Similarly, if you want to avoid sending some files or sensitive data to your images, then you can make use of this dot Docker ignore. So these are certain rules that are followed while writing a Docker file, and this is a very important topic from the interview perspective. Okay, so what are the rules, standard rules to create a Docker file? Now we have already discussed what is a Docker Hub. So Docker Hub is a web portal which provides all the Docker images publicly or privately. So you can either push the images to Docker Hub, and these images can be stored publicly. But if you want to avoid, or let's say you don't want to make the images public, you can also push private images to Docker Hub. For that, you have to create your own account on Docker Hub, and you can push the private files to Docker Hub. So it is similar to the marketplace that is available in AWS portal. Okay, here you can find the Docker images which are provided officially by Docker or other providers. Okay, so let us explore that also. So you can just type hub.docker.com. So just you follow this URL, that is hub.docker.com, and this is where you will be able to find the different images. So here you can just search for image. So let's say I want the Ubuntu image. Now I told you that if you are installing Ubuntu as an entire package from the internet, okay, as an entire operating system, that will be in several GBs. Let's say for example, I'll show you install, or let's say download Ubuntu image. So let's say if I just go and download the Ubuntu image, so that image will be in certain GBs. You can see here it is around 5.8 GB. So if I download this in my laptop, I have to first install the virtualization software. Then I have to install this image which will be of 5.8 GB. and then after that I have to allocate certain RAM and CPU to this Ubuntu, and after that in my Windows laptop I will be able to run Ubuntu virtual machine. Okay, that is what happens with virtualization. But in case of containerization, these images are available on Docker Hub, but if you open and check the size of these images, I'll show you. The size will be mentioned somewhere here. Let's see. Okay, we'll go in the tags here. That will give you the size of the image. Now you can see what is the size of this image that is available here. The size of the image is 28 MB. So I told you, when you are using containerization technology, you don't have to download the entire operating system. Only additional files that are required for the Ubuntu system to run to function smoothly, that those additional files will be downloaded, and you don't have to install the entire operating system. So this is also an image, but this is just a image which has additional files that are required to be run on top of containers. So you using this image, you will be able to create Docker containers or of, let's say, Ubuntu container, right? But this is an entire Ubuntu operating system. So this is an image of Ubuntu. This is an Ubuntu operating system. So this will be done with because of virtualization. So for virtualization, you have to download this entire image and you have to install the operating system, and you have to allocate dedicated RAM and CPU for it. But that is not a case with Ubuntu container. So you have to just download this additional size, that is hardly 28 MB. You will download this and you can start working with Ubuntu container. So that is a major difference between virtualization and containerization. Containerization is quite useful. It will not take you don't have to dedicate additional RAM or resources to your to for your mini virtual machines, or you can say containers, and they will not consume additional storage. They are lightweight. So these are, you can see, these images are hardly of few MBs. You see, and irrespective of what base or what operating system is there on your base in your physical server, this can be easily set up on top of that. Okay, on top of that base machine, these containers can be easily created. So that is what Docker Hub is. Okay, now here you can find the images that are provided. These are some official images. So if I go back to the dashboard, you can see you will find certain official images. Let me search Ubuntu again. You can see there are some official images that are provided by Docker. So whenever you are writing a Docker file, always use official images. Like, that is what is preferred. If not, then you can go for custom images, but always use the official images that are provided by Docker, because this is an open marketplace. Anybody can create an image and they can push the image to Docker Hub. So always use official Docker images, or let's say verified Docker images. Okay, so that is what is required to be used, and that you can see this is the icon. So this is the official image that is provided by, or that is available on Docker Hub. So this is the Ubuntu official image available on Docker Hub. So that is the rule that you need to follow while writing the Docker file. Always use, or let's say, trusted images, not only let's say official images, but always use trusted images. The images has to be trusted. Okay, so nobody, like, I told you already, anybody can create an account on Docker Hub and they can start pushing the images. So it is always suggested to use trusted images. Now in the Docker Hub, you can find the images which are officially provided by Docker, or let's say verified publisher, or which are sponsored by others. So all these images, but this entire content is trusted one. Okay, either the sponsored or verified or Docker images, these entire three type categories, they are the trusted content. So use these trusted images only. Now we can also push and store our private images in Docker Hub by creating an account in Docker Hub. So you can also create an account here in Docker Hub. So you can just sign up, and follow the process, and you can easily create an account on Dockerhub, and that account will help you to push your private images. Now this is what I have shown you already in the diagram here. This is the workflow, that images will be stored in Dockerhub, and from these images you will be creating the containers. But you can also create custom images by writing a Docker file. That is what I have shown here. So either you can create an image by writing a Docker file, or you can also pull the images from Dockerhub. Altogether, by using the Docker image, you can create the Docker containers. So the containers are created from the image, and these images can either be custom created by using a Docker file, or they can be pulled from the Docker hub. So that's it from my side. So this is the theory of Docker. So we will be discussing some more additional components, some more additional topics related to Docker, and when we will be doing the practical, you will get more clarity. But still, if you have any questions, then you can go ahead and ask the questions.